All right, so the purpose of this video is to do a quick recap of least common multiple, so you have it to compare to greatest common factor. Remember, with least common multiple, it's like you're counting by each of those numbers. So you're looking for something that's going to happen in the future or when you happen to get multiples of something. Once again, we have three different methods for finding the least common multiple, just like we did for greatest common factor. It's going to be really important that you are careful in how you apply these three different methods, because while they're very similar to the greatest common factor, there are slight differences, and you want to make sure that you don't confuse the two. Our first method is going to be called the list method again, just like it was where we called it like the rainbow method. It's going to be that same type of idea. So we have the list method that we're looking at. With the list method, it's kind of like the rainbow method, except for now you're counting by these numbers. So here I might have 2 and 7, and I'm just going to count. So it'll be like 2, 4, 6, 8, 10, 12, 14, 16, and so on. And then I'd count by 7, so it'd be 7, 14, 21, 28, and so on. With the list method, you just have to go until you find something that they have in common. You're going to find the smallest one they have in common. So in this case, the first thing they would both have in common would be 14. This is where multiplication tables also come in handy, because you can look along. If you have one that has both of the numbers that you're looking at, you can look for their multiples for something that they have in common. So just keep in mind you're looking for a common multiple and you're looking for the smallest. List method works the same if you're using three numbers. Right, so here we'd have 3, 6, 9, 12, 15, 18, 21. 6 would be 6, 12, 18, 24. 9, 18, 27. And here we would see that their first common multiple for all three would be 18. Now, with these smaller numbers, it's not too bad using the list method, and actually can go fairly quickly. The only thing you have to be careful of is sometimes you get bigger numbers, and so then you don't necessarily know the multiples, or you end up having to go for quite a while, and so you just have to be aware of how you're using the tools. Our second strategy that we're going to look at, just like when we did greatest common factor, is going to be using prime factorization. We're going to start once again just with our factor trees. So 14 would be 2 and 7. 35 is going to be 5 and 7. And then 49 is just going to break into 7 and 7. These were fairly quick. They both factored into their prime number. All three factored into our prime numbers right away. I'm going to list out my prime factorizations. So when I start doing that, 14 is 2 times 7. 35 is 5 times 7. And this is 7 times 7. Just like greatest common factor, I'm going to look for what do all three have in common. In this case, all of them have a 7 in common. So our least common multiple is going to have that number that's going to represent what all of them have in common. And then what's different with least common multiple from greatest common factor, remember, is that they only have to have, just two of the numbers have to have a number in common. In this case, there's nothing else between all three of the numbers, or even just two of the numbers that are in common. So we're just going to multiply by those leftover numbers. So think like L includes the leftovers, so we have to include anything that was not highlighted. And now we're just going to multiply. For mental math reasons, I'm going to do my 7 times 7 first, which is 49, because when I do 2 times 5, it's 10. So now when I do 49 times 10, I get 490. So the least common multiple of 14, 35, and 49 would be 490. So obviously you can use the list method, you can use prime factorization. Once again, I'm going to encourage you to kind of use the cake method, just because I like the fact that you're able to decompose all of your numbers at once, and it doesn't necessarily take a bunch more work. With the cake method, it's also going to be applied slightly differently than the greatest common factor, so you want to make sure that we're just looking at it and knowing which one you're doing. I'm going to start with my 50 and 110. I'm going to go ahead and draw that first layer. Now they both end in 0, so I know that I can divide them each by 10. 50 divided by 10 is 5. 110 divided by 10 would be 11. 5 and 11 are both prime numbers. They can't go into each other, so it's just 1. And I'm going to bring down my 5 and 11. Now here's the difference. Remember with greatest common factor, we were only multiplying the numbers along the side. With least common multiple, because it starts with that L, we're going to be making an L shape. You're going to multiply all of those numbers. So our least common multiple is going to be what would be the greatest common factor, so 10 times 1. And then we're going to multiply by the leftovers, which would be 5 and 11. So I have 10 times 11, which would be 110 again. Then I'll multiply that by 5, which would give us 550 is the least common multiple. I'm going to have us look at one more. If you wanted to pause the video and try this one on your own, I would go ahead and do that. But there are a few changes we have to make because it's least common multiple with 3 numbers. I'm going to draw my first layer. Now they're all even, so I'm going to start with just a 2. 18 divided by 2 is 9. 36 divided by 2 gives me 18. And 54 divided by 2 is 27. Draw another layer. Now 9, I know, happens to go into 18 and into 27, so I'm going to go ahead and factor out my 9 right away. If you didn't realize it, you could have done a 3. 9 divided by 9 is 1. 18 divided by 9 would be 2. 27 divided by 9 would be 3. At this point, I can't go any further because we have that 1, and 2 and 3 are both prime and they don't share any common factors. I'm going to make that L. So my least common multiple is going to be 2 times 9 times 1 times 2 times 3. Or we could do 2 times 2 is 4 times 3 is 12. 12 times 9. And then 12 times 9 gives us an answer of 108. So our least common multiple would be 108. One thing that I want to point out with the cake method, or really with the any of these methods, so the cake method or the prime factorization, when you have 3 numbers, so say for example we had 5 and then we had 15 and 30. When I'm doing like the cake method, I can say, okay, 5 goes into all of them. So I'm going to factor out a 5. So then I'd have 1, 3, and 6. With greatest common factor, we'd have to stop at this point, and it would just be 5 because we had that 1 there. With least common multiple, we can actually go further as long as there's something in common between 2 of the numbers. So like for example, 3 and 6 can both be divided by 3. That 1 is just going to remain the 1 because there's nothing we're doing with it. 3 divided by 3, now that becomes a 1. 6 divided by 3 is 2. And now we multiply these numbers. So in this case, 5 times 3 times 2 times 1, which is 5 times 6, or 30. So their least common multiple would be 30. So just keep that in mind as we're going. And if you have questions about it, make sure you ask.